Hello, grade 7 students. I hope you are all fine. This is a mathematics lecture. It's lecture 2, and the title of our lesson is Algebraic Expressions, and it's part 1 of our lesson because this lesson I divided it into 2 different parts. Before I start with this lesson, this is a very, very important lesson for grade 8 and grade 9. This is a basic lesson for grades 8 and 9. So please, while you are watching the video, as usual, take notes on your math copybooks, study these notes, and at the end of the lecture, we have exercises. Try to solve these exercises, and we are going, of course, to solve them together on Zoom. Now, what are the objectives of our lecture? Objective number 1, we will define an algebraic expression. Objective number 2, identify monomial or term. What is a coefficient? What is a variable or an unknown? Objective number 3, we will collect like terms, or we call them similar monomials. Objective number 4, identify literal writing of monomials. So as you can see in this lesson, we have 4 objectives to finish. Define an algebraic expression. In mathematics, till now, we are studying something called a numerical expression. What is a numerical expression? It is a mathematical sentence containing numbers and operations plus, minus, divided by, and times. Examples of a numerical expressions: 6 minus 2 is a numerical expression because we have numbers and an operation in between. 4 plus 3 times 5 minus 7. This mathematical sentence, we call it a numerical expression. Also, in this numerical expression, we have numbers. We have 4, we have 3, we have 5, we have 7, and we have operations, the plus, the times, and the minus. Now, the second kind of expressions in mathematics are the algebraic expressions. We call them algebraic expressions or literal expressions. So they have 2 names. Some books call them algebraic expressions and other books call them literal expressions. What are algebraic expressions? An algebraic expression is a mathematical sentence containing numbers and operations. So it is similar to the numerical expression because it has numbers and operations, plus, minus, times, and divided by. In addition to the numerical expression, it also has letters. So in an algebraic expression, we find numbers, operations, and letters. A, B, C, X, Y, etc. So you can use any letter you like. These letters, the A, B, C, X, Y, Z, T, etc., are called variables or unknowns. So the letters in an algebraic expression in mathematics, we call them variables or unknowns. They are values, but we do not know exactly their number, how much is it. Now I will give you examples of algebraic expressions. As an example of an algebraic expression, 2 plus x. So in this algebraic expression, we have the number 2, we have the operation plus, and we have the unknown or the variable, which is represented by the letter x. The second algebraic expression, we have 3x minus 1. 3 is a number, x is an unknown, minus is an operation, and 1 is a number. Another example of an algebraic expression, 7 minus x plus 2y minus 3. 7 is also a number, minus is an operation, x is a letter or a variable, plus is an operation, 2 is a number, y is a variable or unknown, minus is an operation, and 3 is a number. So it's very important to differentiate between a numerical expression and an algebraic expression in mathematics. Now, when I talk about a term or a monomial in an algebraic expression, so in any algebraic expression, I have something called a term or a monomial. So a term or a monomial are the same thing I'm talking about here. In any algebraic expression, there are terms or monomials. What do we mean when we say a term or a monomial? Each monomial has a sign, a coefficient, a variable, or more than one variable. The variable, of course, might have an exponent or a power. When we talk about a sign, the sign of a monomial or a term might be a positive or a negative. When we talk about a coefficient, the coefficient is a number, 2, 3, it might be a fraction, 1 over 2, 3 over 5, it might be a decimal number, 1.3, 2.7. When we talk about a variable or a variables, in a monomial, we might find one variable, for example, x. Or we might find more than one variable in a monomial. We might have, for example, x, y. Also, the variable might have an exponent. So we might find a monomial which is, for example, x squared or y cubed. Now I will give you an algebraic expression and I will talk about each monomial in it. In this algebraic expression, there are 4 monomials. 3y is a monomial, minus 2x squared y cubed is another monomial, plus 5xy squared is a third monomial, plus xy is a fourth monomial. Let me talk about each monomial alone. First, I said a monomial should have a sign. So if I look at 3y, there's no sign in front of it. And I said, if we have no sign, this means it's a plus sign. So the sign is plus. What is the coefficient? The coefficient is the number before the variable. So 3 is the coefficient of this monomial. Who is the variable? It's the letter. So y is the variable. If I look at the exponent, y has no exponent. So the exponent is 1. Let me talk about the second monomial, minus 2x squared y cubed. The sign is minus, the coefficient is 2. Here I have two variables. I have x and y. The exponent of x is 2 and the exponent of y is 3. Now plus 5xy squared. The sign is positive. The coefficient is 5. I have two variables, x and y. Here x has an exponent 1 and y has an exponent 2. Plus xy, the sign is plus. The variables are x and y. X has an exponent 1 and y has an exponent 1. So this is if we are talking about a term or a monomial in an algebraic expression. Now, in specific, I will talk about like terms or like monomials, or we call them similar terms or similar monomials. Similar, they have something in common. Which terms do we call them? Like terms or similar terms, like monomials or similar monomials? Please write this note. Two terms or two monomials are like or similar if they have same variable or variables. Also, the variable or the variables should have the same exponents. Now, I will give you examples. Here, 3x is a monomial, minus 7x is a monomial. I don't care about their signs. To see if they are like terms or like monomials, I don't care about the sign, I don't care about the coefficient. What I care for is I should see if they have the same variable or variables. In the first monomial, or in the first term, the variable is x. In the second term, the variable is x. So x is the only variable in both terms. It's not enough only to have the same variable. The variable should have the same exponent. What is the exponent of x here? The exponent of x in the first one, because it has no exponent, so the exponent is 1. In the second one, also x has no exponent, so the exponent is 1. So in this monomial and in this monomial, since we have the same variables x and both x's have the same exponents 1, then they are like terms or similar monomials. Let us talk about the second one. I said the first monomial is 4x squared. The second monomial is 3x squared. I want to see if they are like or similar. I don't care about their signs, never I care about their coefficients. I look at the variable in the first one, it's x. The variable in the second one is x. So till now they have the same variables. Let me see the exponent of x in the first one. The exponent of x in the first one is 2. In the second one, the exponent of x is also 2. So since we have the same variable, the same exponent, these two, we call them like terms. Let me move on. Minus x squared yz cubed, 2x squared yz cubed. To see if they are like or similar, I look at the variable in the first one. Here I have x and here I have x. Now, the exponent of x in the first one is 2. The exponent of x is 2. I continue. Here I have y, and in the second one, here I have y. Here the exponent of y is 1. Here the exponent of y is 1. Also, I continue. The third variable in the first one is z. The third variable in the second one is also z. Here the exponent is a 3 and here the exponent is a 3. So in both monomials, we have the same variables and each variable has the same exponent. Then these two are called like terms. Now minus 2x cubed and minus 6x5. In the first term, I have the variable x. In the second term, I also have the variable x. But the exponent of the first x is 3, while the exponent of the second variable, which is x, is 5. Do they have the same exponents? No. When the exponents differ, then the two terms are not like. Now 5x cubed y4 z square, 7x cubed y cubed z square. I start with the first variable. Here we have x. In the second one, we have x. Here the exponent is a 3. In the second one, also the exponent of x is a 3. I continue to the second variable. Here the variable is y, and here the variable is y. In the first one, the exponent of y is 4. In the second one, the exponent of y is a 3. Do y in both have the same exponents? No. So these, I don't continue to z. These two terms, we call them not like terms or unlike terms. So please, these examples are very important to know if two terms are like terms or different terms. I will continue. Now, before I continue, I want to erase what I have written before. In this slide, I will talk about literal writing of terms or monomials. What do I mean by literal writing? It is a simplified way to write any monomial. So If you are given a monomial and you want to write it in a simplified way, we use the literal writing. Directly, I will give you examples. Suppose I gave you, for example, 2 times x. Always, when we multiply a number by a variable, it can be written in a more simplified way. So 2 times x can be written as 2x. So whenever we see 2x, what does this mean? It means that 2 is multiplied by x. Another example, 3 times a times b squared. It can be written 3ab squared. So this is the simplified way or the literal writing of a monomial. 3 is multiplied by a multiplied by b squared. For example, if I have y times y times y, how do I write it? Y cubed. Because here I am multiplying the same letter by itself, so I write it as an exponent. Now a plus a, how is it written? It is written 2a. As if here I have written a plus a as a multiplication sentence first. I change it to a multiplication sentence, 2 times a. Then from 2 times a, I go to write it as 2a. I will give you another example. Suppose I gave you, for example, x squared times 2 times y. How can I do this as a literal writing or in a simplified way? Always pay attention to something very important. To write a monomial, in the final position, 2x is a monomial, 3ab squared is a monomial, y cubed is a monomial, 2a is a monomial. As you can see something, or as you can notice something, always we write sign, coefficient, variable. Here the sign is positive, the coefficient is 2, the variable is x. 3ab squared, sign positive, coefficient 3, variable a, variable b squared. Y cube, what is the sign? It is 1, sorry, it is plus because we have no sign. What is the coefficient? Any monomial without a coefficient, its coefficient is 1. Only when the coefficient is 1, there is no need to write it. So the coefficient 1, it's no need to write 1y cubed. We write directly y cubed. Now, let me talk about this example. I want to write it in simplified way. What is the arrange? How can I arrange it here? We know first we should write the sign. So positive times positive is positive, times positive is positive. I can write plus and I can write it without a plus. Now, what is the coefficient here? It's 1. 1 times 2, 2 times 1. So we write the coefficient, which is 2. Now I write the first variable x squared with its coefficient. Then I write the second variable y. Again, I will give you another example. For example, I'm multiplying x times y squared. I want to write it in a simplified way. As I said, to write it in a simplified way, I do it like this. First, I need the sign. What's the sign of x? It's positive. What's the sign of y squared? It's positive. So positive times positive is positive. I don't write it. What's the coefficient of x? No coefficient, which means the coefficient of x is 1. What's the coefficient of y squared? It's 1. So 1 times 1 is 1. No need to write 1. Directly I write the answer is x y squared. So please always keep in mind that whenever a monomial has a coefficient 1, it's no need to write the coefficient 1. Till here, I'm done with our lecture for this week. Of course, at the end of the lecture, as I said, I have At the end, so at the end of the lecture, I have more than one slide on which there are exercises. So you can solve these exercises, and we are going, of course, to solve these exercises when we meet together on Zoom. Please watch this video well, understand well, take notes. It's very important to take notes, guys. Take notes, and until we meet on Zoom, I hope you will all be good. Bye.